Hi, 8th grade. Welcome to your Topic 6 review. Remember, all of these questions are extremely similar to the questions on your test. Number 1, which figure is a translation of figure 1? Remember, translation just means a slide, moving it up, down, to the left, to the right. So we're not flipping around at all. So we want it to have the same orientation. Figure C is not, because that was a reflection. Figure A is also a reflection. And figure B is not even the same size. So figure B is a dilation. So the answer is none of the above. Number 2. The vertices of figure KLMN are K is -2, -1, L is -2, -3, M is -5, -3, and N is -5, -1. If figure KLMN is reflected across the line x equals 2, find the coordinates of vertex N. So we're only worried about, or N prime. We're only worried about N. On your test, I will give you scrap graph paper so that you can practice these. But I would say, so N is at -5, so 1, 2, 3, 4, 5, and -1. So here's the original N. It's at -5, -1. They want us to reflect across the line x equals 2. Remember, the line x equals 2 is where it intersects the x-axis at 2. So that line is here. So I want to count how many spaces N is away from that. So it goes 1, 2, 3, 4, 5, 6, 7. So I need to go 7 to the other direction. 1, 2, 3, 4, 5, 6, 7. Okay, and that's going to be where N prime is. So I didn't move up and down at all, so that means my y coordinate is still -1. But my x coordinate has changed to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So the point N prime is at 9, -1. Number 3. What are the vertices of the resulting image A prime, B prime, C prime, D prime, E prime after rotating the figure 90 degrees about the origin? Remember, 90 degrees, X and Y switch. And right now, it's in the first quadrant. And I know if we rotate it 90 degrees, it's going to be in the third quadrant. And in the third quadrant, X is negative and Y is positive. So A right now is at the point 4, 5. So that means A prime is going to be, switching X and Y is 5, 4, but I know that the X value has to be negative. B is at 4, 4. Turns into B prime. I switch X and Y, well, it's still 4, 4. But remember, the X is negative. C is at 5, 4. Which means C prime turns into 4, 5. X is negative. D, 2, 1. You guessed it, turns into -1, 2. And last but not least, E is 1, 2. Flip-de-doo, 2, 1. The 2 is negative. All right, question number 4. Draw the image of ABC after a translation of 3 units right, 1 unit down, and a reflection across the y-axis. So I'm going to translate first. 3 units to the right and 1 unit down. This becomes A prime. 3 units to the right, 1 unit down. This becomes B prime. 3 units right, 1 unit down. That's C prime. So I've done the translation. Now I need to do the reflection across the y-axis. So however far each point is away from the y-axis, I'm going to do that in the other direction. So this is C double prime, B double prime, and, oops, one more, A double prime. Translation and reflection. These are congruent because we didn't change the size. Number 5, consider the figures on the coordinate plane. Which two figures are congruent? I see figure A and C. Part B, describe the sequence of transformations that maps the congruent figures. Oops. Come on. Okay, so A to C. I know that there is a reflection happening, not a reflection, a rotation. I want to turn it. So I'm going to turn figure A 270 degrees. So rotate 270 degrees. So this point 1, 1, remember we switch x, y, that would be here. 2, 2 is here. So that's 1, 1, 2, 2. This is 4, 2 becomes 2, 4. And 4, 1 becomes 1, 4. So here's my new figure. Now it's facing the same way as figure C. So I just need to move it up and over. So that is a translation. So translate up 2 and to the left 4. Those figures are congruent. They're the same size and the same shape. There's a sequence of transformations that maps figure A to figure C. Number 6, is AEFG similar to ABCD? Explain. Yes, because if you dilate, we're going from AEFG to ABCD. So we're going from the big one to the small one. So is it an enlargement or a reduction? It's a reduction. So we know it needs to be a number smaller than 1. We are going from a side length of 2 to a side length of 4. That means we are dilating by 1/2. If you dilate 1/2, AEFG maps to ABCD. All right, number 7. Triangle ABC is similar to DEF, so we know they're similar. If they are similar, we know angle, angle. We know all the angles are congruent. What is the sequence of transformations that maps ABC to DEF? So remember, order matters. So I want A to be on top of D, and I want B to be on top of E, and C to F. So I know I need to flip this over. I know I need to do a reflection. So I'm going to cross off A and D because I'm reflecting. Then we need to see, are we reflecting across the x equals -1 and then translating up 3, or reflecting over the y? So we'll try both. X equals -1, we can just reflect 1 point. If x equals -1, A gets reflected to here. And then if we moved it up 3, boom, right on top of D. So B must be our answer. But let me show you why the other one is not. So if we reflect it across the y-axis, A would be here. And then it says up 2, left 1, and that puts us there, which is not where we want to be. Number 8, in figure B and C are parallel lines. Which of the following statements is true? Select all that apply. Remember, select all that apply means that there's more than one answer. So measure of angle 2 and 7. Well, first what I'm going to do is I see this 72. I know angle 2 is also going to be 72 because of vertical angles. I know 7 is going to be 72 because of corresponding. And I know 5 is going to be the same because it's vertical to 7 and corresponding to 2. So all the ones that are yellow are congruent, which means all the ones that are in green are congruent. So is measure of angle 2 equal to measure 7? Yes. Is measure of angle 1 equal to measure of angle 5? Yes. Is measure of angle 5 equal to 72? Oh wait, back it up. back it up. Is measure 1 equal to 5? No, 1 I put in green and 5 I put in yellow. I hope someone caught that. Is measure of angle 5 equal to 72? Yes, those are called alternate interior angles. Is measure of angle 3 equal to 90? No. Is measure of angle 6 equal to 108? I'm not sure. I know this one's 72. And I know that together, these two angles are supplementary. So let me see. 180 minus 72. Look at that. 108. Number 9, what is the value of x? Remember that all three angles in a triangle are equal to 360. So if we do x plus 5 plus 7x minus 5 plus x, it's got to be equal to 180. Combining like terms, I have x, 7x, and x. Remember that there's technically a 1 in front of those x's. So 7, 8, 9x. And then I've got a positive 5 and a negative 5. Those numbers are opposites. They cancel each other out. So 9x equals 180. To solve for x, I'm going to divide by 9. X equals 20. Boom. Last but not least, are these triangles similar? What are the measurements of their angles? Remember, to find if they're similar, we have to find two angles that are congruent. So this is 90, this is 90, and this is 90. Solving for x first, I know that all three of those equal 180 because they form a straight line. So 3x plus 90 plus 6x equals 180. Combining like terms, 3x plus 6x gives me 9x. Bring down the plus 90 equals 180. Trying to solve for x, I'm going to subtract 90 from both sides. Cancels out on the left, and we get 9x equals 90. Dividing by 9, cancels out on the left, and we're left with x equals 10. So if I plug that back into the original figure, I know 3x, that must mean this is 30. 6x, that must mean this is 60. So to find out if they're similar, we need two angles that are the same. I've got 90 and 90, but then 30 and 60. I got to find the third angle. So I know 90 plus 30 is 120. So if I do 180 minus 120, that gives me 60. So that tells me this other angle is 60, meaning yes, the triangles are similar. They have two angles. So yes, they're similar, and the angle measures are 30 degrees, 60 degrees, and 90 degrees. All right, 8th grade, good luck on your test. I know you're going to do great.